Have you ever heard about the Pioneer Anomaly? If not, you're in for an intriguing journey through space and science. Picture this: the Pioneer 10 and 11 spacecraft, twin probes from NASA embarking on a grand voyage out of our solar system. Their mission to gather data about the outer planets and the interstellar medium. All was going according to plan until around 20 astronomical units from the Sun, something peculiar happened. Both spacecraft began slowing down more than anticipated, a small yet significant deviation from their predicted accelerations. This strange occurrence, first observed in the 1980s, was dubbed the Pioneer Anomaly. It sparked a flurry of confusion and intrigue within the scientific community. What could be causing these spacecraft to veer off course? So the Pioneer Anomaly was a real head-scratcher for scientists. But what were their theories for this unexpected behavior? In the quest to solve the Pioneer Anomaly, scientists turned to various theories. The Pioneer 10 and 11 spacecraft, after journeying about 20 astronomical units from the Sun, were slowing down slightly more than expected. This unexplained deviation from their predicted accelerations was initially noticed in 1980 and became a serious subject of investigation by 1994. The theories proposed to explain this anomaly were as diverse as they were intriguing. One such theory pointed the finger at our understanding of gravity itself. Some scientists questioned whether there might be errors or gaps in Newton's laws of gravity that could account for the spacecraft's unexpected behavior. Could it be that our understanding of these fundamental forces was incomplete or incorrect? This possibility, although fascinating, did not provide a satisfactory explanation. Another theory suggested that the anomaly might be due to leaks in the spacecraft. Perhaps some form of propulsion was being generated by gas leaks or even the emission of heat from the spacecraft. However, this theory also fell short. The spacecraft were extensively checked for leaks, and none were found that could account for the observed anomaly. The endeavor to understand the Pioneer Anomaly was marked by a relentless pursuit of knowledge. Scientists meticulously analyzed data, recalculated trajectories, and revisited theories in their quest for answers. Each investigation, each theory, and each calculation was a testament to the scientific process at its best. Yet, despite the multitude of theories and the exhaustive investigations, none seemed to fully explain the anomaly. The answer, it turned out, was quite literally staring us in the face. The key to solving the Pioneer Anomaly lay not in the far reaches of space, nor in the complexities of gravitational physics, but rather in the very spacecraft themselves. It was a solution that was as humbling as it was enlightening, reminding us that sometimes the answers to our most perplexing questions can be found in the most ordinary of places. The solution to the Pioneer Anomaly came from a source that was with the spacecraft all along: heat. The Pioneer spacecraft were not just floating chunks of metal, they were powered by intricate systems known as radioisotope thermoelectric generators, or RTGs for short. These generators work by converting the heat from decaying plutonium-238 into electricity. It's a bit like a nuclear power plant, but on a much smaller scale and with no moving parts. Now, heat is a form of energy, and in the cold, empty vacuum of space, there's only one way for that energy to escape: through thermal radiation. Just as the Sun radiates heat and light out into space, so too did the Pioneer spacecraft radiate the heat generated by their RTGs. But here's the thing about radiation: it doesn't just vanish into thin air. Instead, it carries momentum, and when an object emits radiation, it experiences a tiny push in the opposite direction. This is known as the recoil effect of thermal photons. So imagine if more heat is being radiated in one direction than in the others. This could be due to the shape of the spacecraft, the placement of the RTGs, or any number of factors, but the result would be the same: a slight but steady acceleration in the opposite direction. Just like a person in a rowboat who pushes off from the dock and slowly drifts out into the lake. They're not rowing, they're not using a motor, they're just letting the recoil from their push carry them away. That's what was happening with the Pioneer spacecraft. They were drifting away from the Sun a little bit slower than expected because they were constantly being pushed gently back towards it by the recoil effect of their own heat radiation. This concept, known as the recoil effect of thermal photons, was the key to solving the Pioneer Anomaly. It's a fascinating example of how even in the vast emptiness of space, every little bit of energy counts. And it's a reminder that sometimes the answers to our biggest questions can be found in the smallest details. By 2012, after years of meticulous research, the mystery of the Pioneer anomaly was finally solved. A series of research papers had emerged reanalyzing the thermal forces at play. The consensus was clear. Once the thermal recoil force was properly accounted for, no anomalous acceleration remained. Now, you might be wondering, what is this thermal recoil force? Well, remember the radioisotope thermoelectric generators, or RTGs, that powered the Pioneer spacecraft? They convert heat from decaying plutonium-238 into electricity. This heat in the vacuum of space can only escape through thermal radiation. If more heat is emitted in one direction due to the uneven distribution of heat, it results in a slight acceleration in the opposite direction. This is the thermal recoil force. The most detailed analysis, conducted by some of the original investigators, compared two methods of estimating thermal forces. Method 1 used a comprehensive thermal model of the spacecraft, while the second method used telemetry data. The results, no significant difference between the two. This confirmed that the anomaly was not due to unknown physics or overlooked factors, but could be fully explained by the physics we already know. The Pioneer anomaly, a puzzle that had baffled the scientific community for decades, was solved not by exotic physics or extraterrestrial interventions, but by the mundane, everyday physics of heat. It's a reminder that in the vast expanse of space, even the smallest forces can have significant effects over time and distance. The resolution of the Pioneer anomaly underscores the complexities involved in space exploration and the importance of considering all possible variables in scientific investigation. It's a testament to the power of scientific inquiry and a demonstration of how sometimes the simplest explanation is the right one. The solution to the Pioneer anomaly reminds us that sometimes the most extraordinary mysteries have very ordinary explanations. The resolution of the Pioneer anomaly has had a lasting impact on the field of space exploration. This intriguing puzzle, which began as an inexplicable deviation in the paths of Pioneer 10 and Pioneer 11, ultimately led scientists to a deeper understanding of the forces at work in the vacuum of space. The anomaly served as a poignant reminder of the complexities that come with venturing beyond our planetary boundaries. It underscored the importance of considering all possible variables in scientific investigation. In the case of the Pioneers, it was the seemingly innocuous heat emissions from their power sources that were causing the unexpected change in their velocities. This discovery reinforced the idea that when it comes to space exploration, there's no such thing as a small detail. Every component, every action, every bit of energy matters. It all adds up and can have significant effects on a spacecraft's journey. The Pioneer anomaly taught us that even the heat generated by a spacecraft's power source, something that might be overlooked in the grand scheme of things, can influence its trajectory in a measurable way. But the Pioneer anomaly did more than just remind us of the intricacies of space exploration. It also highlighted the power of scientific investigation and the importance of perseverance in the face of mystery. It showed us that even when faced with seemingly inexplicable phenomena, thorough investigation, consideration of all variables, and a bit of creative thinking can lead to solutions. The Pioneer anomaly also serves as a testament to the fact that science is ever evolving, always learning and adapting. It shows that our understanding of the universe is constantly being refined, and that sometimes the answers to the most perplexing questions can be found in the most ordinary of places.